We're back for the third of our area videos. This one is area of composite shapes. We've gone through area of basic shapes and Heron's formula. Now we're on to composite shapes. And just a reminder that composite shapes are two shapes stuck together. So our first example, use the area formulas for shapes and add the total together. So what have I got here? Looks like a bit of an ice cream cone. The composite shape is made up of a semicircle and a triangle. All right, I'm going to use my highlighting tool here and go sorry, it's not straight. That's my semicircle, and we're going to try green here. And not all the time will you have this pretty dotted line. You may have a shape, and you need to try and interpret where the imaginary dotted lines could be. So I've got my green triangle and I've got my pink semicircle. So the first step says to calculate the area of the semicircle. The second says calculate the area of the triangle. Now once we found both of those, we add them together. All right, back to my pen. So I'm going to start with my semicircle. And remembering that the formula of a circle, so I'm going to pop this over here, is pi r squared. Now I only need to know half of this circle for a semicircle. So I halve that formula and I get half pi r squared. Now I've got a diameter equaling 20 centimetres, and I know that my radius is equal to half my diameter, therefore it's equal to 10 centimetres. And I just put things in there. So my semicircle, I'm going to use shorthand there. The area is equal to pi times, what's my radius again? 10 squared, which is pi times 100, and that's 314.15. Do I go further? Yeah, might as well. 314.159. We'll see what the area of the triangle ends up as. Doesn't actually tell me how many decimal places to keep it though. We'll keep it nice and rounded in a minute. Now my triangle. There we go, my triangle. I'm using the formula area is equal to half base times height. Because I have that height through the middle there. It is an isosceles triangle. So with an isosceles triangle, I can, if I have the height through the middle of it, I can use the area equals half base times height formula to find my area. All right, so plugging all my values in, half times my base is 20, it's the bottom of the triangle there, 20 times 24. And 2 times 24 gives me 480. Starting to get big numbers. 4,800, I think it is. No, 480. Don't make me think and count manually at this time of the night. All right, so I've got half times 480. And half of 480 is 240. So the area of my triangle is 240 centimetres squared. Now I'm going to add a little centimetre squared over here on my semicircle. I'm going to change colours so you can see what the total area is. So the total area is equal to the triangle of 240 centimetres squared plus that of the semicircle, which is 314.159 centimetres squared. Again, it doesn't actually tell me how many decimal places. or I'll phrase that it might, but I'm not in the textbook at the moment. So adding them together, so I've got the 0.159455, don't quote me, 554, yep, all right. So approximately 554 about 0.2 centimetres squared, if I was to round it to one decimal place. All right, on to our second example. This shape is comprised of two equal parallelograms and a rectangle. So we need to break this into three parts. So we've got part number 1 there, part number 2 there, and part number 3 there. But you'll notice that part number 1 and 3 are actually the same thing. So we only need to do one calculation, and then we add that figure twice. So our parallelogram, we'll do on the side here, back to blue. Now remembering the parallelogram area formula is base times height. I have as you can see, I've got the double lines here and the double lines here, indicating that my base, or the side length, is 3.5 meters. 3.5, what am I saying? It's a 4. 3.4 meters. And my height is 1.9 meters. Giving me an area of, just plugging this into my calculator again, 6.46 meters squared. So remembering that we're using meters. So onto my second shape. This is the rectangle in the middle. It has one side unlisted, the other side being 1.3 meters. So my area is equal to length by width, and I need to try and identify my length and my width. So I'm going to call this guy down here my 1.3. That's going to be my width. And because I'm using a parallelogram on the outside, I know that this side here is the same as this side here. So my length is 3.4 meters. I'm going to multiply that by 1.3 meters and come up with 4.42 meters squared. Change back again. My total area is equal to area number 1 of 6.46 meters squared. Then I'm going to add on area number 2, which is 4.42 meters squared. Then I'm going to add area number 3. Even though I didn't calculate it, area number 1 is the same as area number 3. So we're going to use the 6.46 meters squared again. And I end up with my total area equal to 17.34 meters squared. And if we were rounding that, it's approximately 17 meters. All right, so we are done with area. Feel free to contact us if you have questions about this, and we'll be moving on to surface area in our next videos. Thanks.